So, Section 7 of Chapter 18 deals with vitamins, or vitamins if you're British. Organic compounds, again, that means they're made primarily of carbon, required in small amounts for normal metabolism, and that the body cells cannot synthesize in adequate amounts. So that makes them essential nutrients. They have to come directly from food, or they could come indirectly in the form of provitamins, which are precursor substances, things. Precursor is something that can become, so a provitamin can become a vitamin. Vitamins get classified into two major groups based on whether or not they are soluble in water or soluble in lipids or fats. So the fat-soluble vitamins are A, D, E, and K, and all the others, all the different B vitamins and vitamin C, are water-soluble. The fat-soluble vitamins, they get stored in the body for a pretty long time in various tissues. That is why excess intake can lead to overdose. So you can get too much vitamin A, D, E, or K. They resist effects of heat, so cooking and food processing don't normally destroy them. The first of these, vitamin A, exists in several forms, including retinol and retinal, or retinine, and then the retinal can be converted into something called retinoic acid. Those substances are in a lot of skincare products these days. There are even prescription forms of a couple of those. They can actually be extracted, or the body can make them from beta carotene. So body cells can synthesize this vitamin from a group of yellowish plant pigments, which are provitamins called the carotenes. And they show us beta carotene here. Of course, carrot sounds like the vegetable carrots, and carrots are rich in carotenes. Pretty much all of your yellow to orange fruits and vegetables are going to have carotene in them. Excess vitamin A or its precursors are mainly stored in the liver. An adult's liver stores enough vitamin A to supply body requirements for a year. Infants and children usually lack these reserves, so they're more likely to develop vitamin A deficiencies. Here is beta carotene, and you can see this ring of carbons at each end. And if you look at retinal and retinol, you notice that they look very similar to the beta carotene from here over to somewhere here in the middle. And that is because you can cut a beta carotene molecule here in the middle, and you'll get two fragments. And I don't remember the details of this, and I don't want to try to figure it out right now. But when you cleave this, when you cut it into, you may get two retinals, you may get a retinal and a retinol. I'm really not sure. But let me show you the difference here. Retinal, the AL suffix, talks about this, which is an aldehyde group. When you have a carbon that is double bonded to an oxygen and that carbon has a hydrogen on it, that's something that we call in organic chemistry an aldehyde. And it gives the al suffix to the name. Now, the retin comes from the retina, and that's because these are used in the retina of the eye to produce a compound called rhodopsin that responds to light. In other words, you need these to see, and that's why the old adage of eat carrots, they're good for your eyes. They really are. Now, retinol, the OL suffix on it tells us it's an alcohol, which means we have a carbon with an OH, which is called a hydroxyl group. And that is probably, without me just looking at every little bit of it, the only difference in these two. Let's see. I'm just scanning real quick. Yeah. The only difference here between the retinal and the retinol is that we have the aldehyde group on the end versus the alcohol group on the end. And retinol can be oxidized and converted into this, which is retinal. That would be done by taking the hydrogen off the oxygen and taking one of the two hydrogens off of that carbon, and that would leave the carbon double bonded to the oxygen. And then that can be further oxidized into something called retinoic acid, which would insert an oxygen between that carbon and that hydrogen. I know. Sorry, I can't help myself. All right. Vitamin A is relatively stable to the effects of heat, acids, and bases, readily destroyed by oxidation, and unstable in light. And it's that light instability that allows changes in the molecule to trigger nerve impulses in the retina. Vitamin A is important in vision. Like I mentioned, retinal is used for making rhodopsin, which is in the rods of the retina, and the light-sensitive pigments in the cones. Remember that the cones in the retina allow us to see colors. The rods just allow us to see light in general. So vision in low light is really dependent on the rods and is very dependent on rhodopsin from vitamin A. Vitamin A and the beta-carotenes also act as antioxidants by readily combining with oxygen and certain oxygen-containing molecules, which makes them highly reactive and damaging to cellular structures. So vitamin A, as an antioxidant, protects your body's tissues from these things. Refer to them here as the free radicals. Only foods of animal origin like liver, fish, whole milk, butter, and eggs are good sources of vitamin A, but carotene is widespread in leafy green vegetables and the yellow and orange colored fruits and vegetables. You can get too much vitamin A. Excess vitamin A will produce peeling skin, hair loss, nausea, headaches, and dizziness. The condition is hypervitaminosis A. Chronic overdoses can inhibit growth and break down bones and joints. Megadosing on fat-soluble vitamins is particularly dangerous during pregnancy. Some forms of vitamin A in excess can cause birth defects. So, deficiency, though, of vitamin A will cause night blindness. Xerophthalmia, or dry eye, is due to a vitamin A deficiency. And vitamin A deficiency can also cause degenerative changes in certain epithelial tissues, and the body would become more susceptible to infection. Vitamin D, now, is a group of steroids. In fact, one of my, I don't know how many of you would have heard of Mr. Wall. Mr. Ben Wall taught biology and anatomy at Walker College and then Bevel State for close to 50 years. He actually taught me around 1979 or 80, and then I had the pleasure of working with him for several years until he retired. He was adamant that vitamin D is not a vitamin. It is a steroid. So one of these substances, vitamin D3, which is also known as cholecalciferol, is found in foods like milk, egg yolks, and fish liver oil, particularly cod liver oil. Vitamin D2, also known as ergocalciferol, is commercially produced by exposing a steroid that comes from a yeast to ultraviolet light. Vitamin D can be synthesized from dietary cholesterol that's been metabolized into provitamin D by intestinal enzymes. Then it gets stored in the skin and exposed to ultraviolet light. So that's where you get the idea of sunlight and vitamin D. Now, a lot of people say it incorrectly, and I hope they don't mean it the way they say it. You do not absorb vitamin D out of sunshine. There is no vitamin D in the air. There's no vitamin D in the sunshine. But what has happened is that cholesterol has been converted to something called provitamin D in your intestines, It is then stored in your skin, and when your skin is exposed to the UV light in sunshine, it is converted then into vitamin D. So getting some sun does help you make your own vitamin D. Like the other fat-soluble vitamins, it resists heat, oxidation, acids, and bases. It's mainly stored in the liver. There will be lesser amounts found stored in the skin, brain, spleen, and bones. It is stored in the form of hydroxycholecalciferol and released as needed. When parathyroid hormone is present, this form of vitamin D gets converted in the kidneys to an active form of the vitamin, which is called dihydroxycholecalciferol. I'm resisting the desire to show you the difference in all of these things. I know you're not really interested in the chemistry of it. This substance then in turn is carried as a hormone in the blood to the intestines, where it will stimulate production of calcium binding protein. In other words, you need vitamin D to absorb calcium from the foods that you eat. And of course, one of the best sources of calcium is dairy products. So it doesn't do much good to, eat dairy, to drink milk or eat yogurt in hopes of getting calcium from it if you don't also have vitamin D. Now, vitamin D gets added to milk. Natural foods are poor sources of vitamin D. It's often added to them during processing. Homogenized, non-fat, and evaporated milk are typically fortified with vitamin D. Fortified means that the nutrients have been added. Enriched means nutrients have been partially replaced. Now, they mention here non-fat and evaporated milk being fortified with vitamin D. That's not very effective in non-fat milk because vitamin D, as a fat-soluble steroid, is only soluble in fat. So the non-fat milk, there's no fat for it to be dissolved in. So it doesn't work very well. As a vitamin D source, you really need whole milk. You can get too much vitamin D. It'll cause diarrhea, nausea, and weight loss. And over time, it can calcify certain soft tissues and can lead to kidney damage. In children, a vitamin D deficiency can result in rickets, where the bones, teeth, and abdominal muscles don't develop normally. Vitamin D deficiency in adults can lead to osteomalacia, where the bones decalcify and get weak. Now, we've got this picture here. You notice how this young man's legs have bowed under the weight of his body. And that is because the bones are too soft, lacking calcium because of the lack of vitamin D. So that is rickets. All right. Vitamin E, a group of compounds, the most active of which is called alpha tocopherol. It's resistant to heat, acids, and light, but unstable in bases and in the presence of UV light and oxygen. It is a strong antioxidant. It's found in all tissues, but mainly stored in muscles and adipose and concentrated in the pituitary and adrenal glands. Precise functions are unknown, but it's thought to act as an antioxidant by preventing oxidation of vitamin A and polyunsaturated fatty acids. It can help maintain stability of cell membranes. It is widely distributed in foods. Best sources are oils from cereal seeds like wheat germ. Other good sources are your salad oils, margarine, shortenings, fruits, nuts, and vegetables. You can get too much, and it'll cause nausea, headache, fatigue, easy bruising and bleeding, muscle weakness. It is so easily obtained, deficiency conditions are rare. Vitamin K, like the other fat-soluble vitamins, exists in several different chemical forms. There's K1, known as phylloquinone, found in foods. K2 is produced by the bacteria called E. coli, Escherichia coli, that normally inhabits the human intestinal tract. So you are going to have E. coli in your colon, and it will make vitamin K2 for you. Vitamin K mainly functions in the liver where it's necessary for forming several proteins. Some of the proteins that lead to blood clots, prothrombin being one of those. Deficiency of vitamin K will prolong your clotting time and increase risk of hemorrhaging. Excess vitamin K can occur in formula-fed infants and cause jaundice, hemolytic anemia, and hyperbilirubinemia. All right. Richest sources of vitamin K are leafy green vegetables, but other good sources would be egg yolk, pork liver. I don't know anybody that eats pork liver. Beef liver, chicken liver, yeah, but pork liver. Soy oil, tomatoes, interesting, and cauliflower are good sources of vitamin K. That's odd to me. I don't think about tomatoes and cauliflower having very much of an oil content for that to be dissolved in. All right, so anyway, all of these fat-soluble vitamins are summarized here in this table. And let's see how we doing on time here. Moving a little slow. Wait a minute, something's missing. Did I just skip? Where are the water-soluble vitamins? Here they are. I did just skip over them. So the water-soluble vitamins include the B vitamins and vitamin C. These can be destroyed by heat when you cook. B vitamins include several compounds essential for normal cellular metabolism. And to get really to the point, what you're going to find with nearly all the B vitamins is that they are involved somehow in metabolism. And again, assuming everyone took Biology 103, which is a prerequisite to A&P 1, you were drugged through the torture of the cellular respiration, glycolysis, Krebs cycle, electron transport chain. If you're not familiar with those, if you don't feel comfortable about them, let me know. I'll see if I don't have some videos that will explain that. I'm pretty sure I do from the Chemistry 105 course, and I'd be happy to share those with you. Give you something else to watch, right? Anyway, what you're going to see as I go through these really quickly is they're nearly always connected to glycolysis, Krebs cycle, electron transport chain. They've got to be there for those things to happen. So the first one, vitamin B1, also known as thiamine, and the name there, amine, tells you that that's what it is. It is an amine. It has nitrogen, possibly with a couple of hydrogens bonded to it, maybe just one. Anyway, crystalline compound called thiamine hydrochloride in its pure form. Heat and oxygen can destroy it, especially in an alkaline environment. It's part of a coenzyme called co-carboxylase that oxidizes carbohydrates. Specifically, it is required for pyruvic acid to enter the citric acid cycle, the Krebs cycle. You can look back to chapter 4 for a review on that, or like I said, if you'd like to see some videos, let me know. Without this vitamin, pyruvic acid will accumulate in the blood. It also functions as a coenzyme in synthesis of ribose, which you need for making RNA. It's mainly absorbed through the wall of the duodenum and transported by the blood. Only small amounts get stored. Excess gets excreted in the urine. It oxidizes carbohydrates, and cellular requirements vary depending on your calorie intake. Recommended daily allowance for adults, 1.2 milligrams. Good sources of food for thiamine are lean meat, liver, eggs, whole grain cereals, leafy green vegetables, and legumes like beans. By the way, as we go through all of these and you see the food sources, you're going to notice a lot of things being repeated, and you also hopefully will notice that to get all of these things without just swallowing a vitamin pill, you need that varied diet. You're going to see lean meats over and over. You're going to see eggs mentioned over and over. You're going to see whole grains mentioned over and over. You're going to see leafy greens mentioned over and over. So anyway, Excess thiamine is not as common as excesses of the fat solubles because you excrete it in urine. However, you can get too much. It can cause vasodilation, cardiac dysrhythmia, headache, weakness, even convulsions. Mild deficiency will produce loss of appetite, fatigue, nausea. Um, Prolonged deficiency leads to a disease called beriberi. Um, and in fact, the word vitamin was coined by a scientist studying beriberi. I was thinking they mentioned him here, but they don't. It's a great name. The guy's name was Casimir Funk. And he thought that all of the vitamins were amines. And so the word vitamin is a portmanteau of vital and amine. So vital, amine, vitamin. Um, and it was his studies on this condition called beriberi that led to that. All right. Beriberi can affect people in developed nations if they are chronic alcoholics, um, but it is required for oxidation of alcohol. So people that are alcoholic are likely to develop thiamine deficiencies. All right, another of the B vitamins is riboflavin, or some people pronounce it riboflavin. In fact, that's what they tell us to do right here. It's B2, it's yellowish brown. Um, it is part of several enzymes and coenzymes known as the flavoproteins. One of these is FAD, which is one of those electron carriers from the citric acid cycle. I know it's going to come up over and over and over. Need about 1.3 milligrams per day. It's found in lots of foods. Rich sources are meat and dairy products, leafy greens, whole grain cereals, enriched cereals. Deficiency produces dermatitis and blurred vision. Vitamin B3 is niacin, also known as nicotinic acid. It is converted to a physiologically active form called niacinamide, and that is going to be related to, here we go, to coenzymes. Coenzyme 1, also known as NAD, and coenzyme 2, called NADP. Once again, Biology 103, glycolysis, Krebs cycle, electron transport chain, that's where you get these. NAD gets reduced to NADH, so on. They're electron carriers in glycolysis, citric acid cycle, and electron transport chain. Required for synthesis of ribose and deoxyribose, which you need for making RNA and DNA. Here is NAD, nicotine amide, adenine dinucleotide. You have adenine over here, a couple of phosphates, and there's your ribose sugar and niacinamide. Readily absorbed from foods. Human cells can make it from tryptophan, which is an essential amino acid. So how much niacin you need depends on how much tryptophan you eat. 14 milligrams for women, 16 milligrams for men. Liver, lean meat, peanut butter, legumes. Milk is not a good source of niacin, but it is a good source of tryptophan, so you can then make the niacin from that. Excess niacin can cause acute toxicity with effects like flushing, wheezing, vasodilation, headache, diarrhea, and vomiting. You get too much niacin, yeah, you will turn red. Chronic toxicity effects include liver problems. Niacin deficiencies have been associated with diets based on corn and corn products, which are very low in niacin and tryptophan. So niacin deficiency causes pellagra, that produces dermatitis, inflammation of the digestive tract, diarrhea, and mental disorders. And pellagra was a big issue in the South 100 years ago. People ate a lot of corn and didn't get enough other nutrients to replace it. Here they mention it here. Serious problem in the rural South, early 1900s. Uh, Less common in cultures that extensively treat their corn with lime to release the niacin bound to protein. Like beriberi, it affects people who consume alcoholic beverages instead of food. All right, vitamin B5 is pantothenic acid. This is a yellowish oil. It is part of coenzyme A, which of course you need. You make acetyl-CoA that enters the citric acid cycle. Told you you were going to hear this stuff a lot. Good sources of pantothenic acid are meats, whole grain cereals, legumes, milk, fruits, and vegetables. Vitamin B6 is 3 different compounds that collectively make up vitamin B6. Pyridoxine, pyridoxal, pyridoxamine. Pyridoxine has an amine group right here, this nitrogen. Pyridoxamine has not only this nitrogen, but it has this amine group up here. Pyridoxal, they don't show you this, but this CHO, the carbon is double bonded to the oxygen, so it is an aldehyde. This one could have been, I suppose, called pyridoxal because there's an alcohol group here on this carbon, but there are a couple of alcohol groups anyway, so that's probably why they avoided using that name. Vitamin B6 functions in metabolism of nitrogen-containing substance. So how much of it you need depends on the protein content in your diet. Let's see, it is abundant in foods, so deficiency is rare. Good sources: liver, meat, bananas, avocados, beans, peanuts, cereals, egg yolks. Excess will produce burning pain, numbness, clumsiness. Gosh, maybe that's the problem with me. Too much B6, that's why I'm clumsy. Diminished reflexes, paralysis. Vitamin B7 is biotin. It is a coenzyme in metabolic pathways for amino acids and fatty acids, plays a role in synthesis of the purine nitrogenous bases, adenine and guanine. Metabolically active organs like the brain, liver, and kidneys will store some of it. Bacteria that inhabit the intestinal tract make it. It is widely distributed in foods. Dietary deficiencies are rare, but it is available in liver, egg yolk, nuts, legumes, mushrooms, and there's no toxicity. Folacin, vitamin B9, also known as folic acid, or you may have heard it referred to as folate, and the name gives you a hint. You get it from foliage. So, folacin readily absorbed from the digestive tract, stored in the liver, converted to an active form called folinic acid that functions as a coenzyme necessary for metabolism of amino acids and synthesis of DNA. Also acts with cyanocobalamin, which is vitamin B12, to produce normal red blood cells. Not surprisingly, liver, leafy green vegetables, again the name folic acid coming from foliage. Excess gets secreted in the urine, so it's rarely toxic. Deficiency leads to megaloblastic anemia. Folacin deficiency has been linked to neural tube defects. Oh gosh, and the word just left me right before I could say it. Spina bifida, that should be mentioned here. Anyway, when a woman is pregnant, there is a crucial period of a few weeks, I want to say at around weeks 9 through 12 of the pregnancy, when the fetus is developing its neural tube. In other words, its spinal cord. There it is. Neural tube defects include spina bifida and anencephaly. Taking synthetic folic acid supplements just before and during pregnancy can greatly reduce the risk of neural tube defects. So, very important during pregnancy to get that folic acid. Naturally occurring folate is a mixture of compounds that collectively have the same activity as synthetic folic acid. I just have to go off on this tangent. Folate versus folic acid. Many acids have a name that says something-ic acid. There's acetic acid, which is in vinegar. There's folic acid. The list goes on and on and on. And what acids do is when they dissolve in water, they give a hydrogen atom away. The hydrogen comes off of the acid molecule and it goes over and joins with water to turn the water into H3O. So what's left behind of that acid molecule when the H comes off gets the name of the acid changed from ic acid to ate. So folic acid, take the hydrogen off of it, what you have left is folate. Acetic acid, which is in vinegar, when the hydrogen comes off the molecule, what's left behind is called acetate. And these things that end with this ate suffix are called conjugate bases. So every acid has a conjugate base. It's the part of the molecule minus the hydrogen. Sorry, the chemistry teacher in me won't let go. All right, cyanocobalamin, B12, has a complex molecular structure with a single atom of cobalt. In its pure form, it's red, and it's stable to the effects of heat, but inactivated by light or strong acids or bases. Now, there's the cobalt in the middle. As you can see, it's a pretty big molecule. All of this surrounding the cobalt is something called a porphyrin ring, which is also found in, what is that green stuff in plants called that allows photosynthesis? Chlorophyll. But the difference is chlorophyll has iron here, where cobalamin has cobalt. All right. Secretion of intrinsic factor from the parietal cells of the gastric glands will regulate cyanocobalamin or B12 absorption. So if your stomach is not producing the intrinsic factor, you'll have trouble absorbing vitamin B12 out of the foods that you eat. Inability of gastric glands to secrete adequate amounts will impair B12 absorption, which can lead to a form of anemia called pernicious anemia, where you get very large red blood cells. And because people do tend to decrease their intrinsic factor production with age, that's why you'll see elderly patients needing vitamin B12 shots. Because no matter how much of it you swallow, you just can't absorb it. Okay, this video is running long. I apologize. Here is ascorbic acid, which is vitamin C, similar to the monosaccharides. It's one of the least stable vitamins because it's easily oxidized, and that makes vitamin C a good antioxidant. It is fairly stable in acids. If you look here, here's vitamin C, and here is glucose. And you can see that there's some similarity there in their structure. Vitamin C is necessary for production of collagen, for converting folacin to folinic acid, and metabolism of certain amino acids. It promotes iron absorption. So if you're taking iron supplements, you also need some vitamin C to be able to absorb it. Not much of it gets stored. If you have any excess, it'll be excreted in the urine or it'll get oxidized. And when it's excreted in the urine, you will know that you are excreting an acid in your urine. It can actually burn. Individual requirements vary. 10 milligrams a day is sufficient to prevent deficiency symptoms. 80 milligrams a day saturates tissues in a few weeks. RDA is 75 milligrams for women, 90 milligrams for men. There was a famous scientist who won 2 Nobel Prizes. I think he's still the only person to ever win 2 Nobel Prizes in 2 different areas. His name was Linus Pauling. And he was a proponent of taking massive doses of vitamin C. He thought that it would protect you from cancer, and he ended up living to nearly 100 before he actually did die of cancer, but he said it would have happened much sooner if it hadn't been for all of his vitamin C. Vitamin C fairly widespread in plant foods, high concentrations in citrus fruits and tomatoes. Leafy green vegetables are also a good source. A cup of broccoli has more vitamin C than an orange. Deficiency of ascorbic acid leads to scurvy, which is more likely to affect infants and children. It impairs bone development, causes swollen, painful joints. The gums can swell and bleed. This used to be a problem for sailors a few hundred years ago, particularly if you're out at sea for months to cross the ocean. So you may have heard some of your movie style pirates talking about someone being a scurvy dog. But because citrus fruits have a lot of vitamin C, that problem was partially solved by carrying limes on voyages to get the vitamin C from the limes. Okay, there's your uh, summary of all of this. I know there's a lot of information, um, and I don't want you to spend an inordinate amount of time on this either. Just know that the B vitamins and vitamin C are water soluble and primarily used in metabolic reactions. Okay, this video has run too long, so I'm going to stop here.